Module 7 Descriptive Statistics Point Estimates. Section 1 Mean. As the name suggests, the descriptive statistics is a set of tools that we use to describe our data set. So we are constricting the whole information of a particular data set into a set of numbers, for example mean, mode, median, standard deviation and so on. In this section we will see something about the mean, what it is. So mean is an example of a test statistic. What is that? It's a numerical characteristic of a sample. So as you know, there are two types of statistic. One is called parametric and while the other one is called non-parametric. So parametric statistics are derived from the moments of the frequency distribution. So these are distribution dependent. Most of the parametric statistics make an assumption that the samples must have come from a population that is more or less normally distributed. So that assumption is invalidated if your samples are come from a not normal distribution, for example log-normal distribution or reciprocal distribution and all. So for that you need to go for a non-parametric statistical test. So these are derived from the percentiles of frequency distribution and these are rank based and distribution independent. So it does not make any assumption about the population's distribution. So these are more robust statistic. So non-parametric statistics tend to be more robust because it is not affected by the outliers, while parametric statistics are affected by the outliers. We will see in subsequent sections we will see what is this moments of frequency distribution really mean and also different kinds of parametric and non-parametric statistic. And throughout this MOOC I have labeled all non-parametric method in red color. So wherever you spot the red color you may infer that these are non-parametric tests. Descriptive statistics describe and summarize, also known as a summary statistics. So it is just to summarize the whole data set into a number with certain error range. As I told you, this is not the best way to summarize a data set. The best way is of course through box and whisker if you have a lot of elements in your data set, or if the elements are less than 100, the best way is to go for a column scatter, a scatter plot with the column at the mean. While descriptive statistics is very commonly used and this is like a backbone of a number of statistical tests that we are going to discuss later. So there are broadly two types of descriptive statistics. One is to measure the central tendency or location or the point estimate. So these estimates are just one number that summarize the entire data set. So it could have a million points, like census of India has got billions point, right? Still it just comes up with just one number. For example, literacy rate of India is just one number, 70.1. So examples are mean. The multiple kinds of means are there: arithmetic mean or average, geometric mean, harmonic mean, then median, mode and percentile. These are all examples of the measures of the central tendency. Other kind of descriptive statistics is not just one number but it's it's a range. So these are measures of dispersion, range, interquartile range, mean absolute deviation, median absolute deviation, variance, standard deviation, coefficient of variation, that is CV, skewness, kurtosis and so on are examples of the measures of dispersion. So what is okay to compute depends upon the measurement scale or level of measurement. For example, if it is nominal range, nothing is okay except frequency distribution. In the case of ordinals range, the level, had it been ordinal, then of course frequency distribution is okay, median and percentiles are still okay. While interval, almost everything is okay except ratio and coefficient of variation, while the case of ratio everything is fine. So it depends upon the measurement level that you can actually compute it. If I ask you a question that IQ score, can you do an average of IQ score? For example, a parent has got 4 kids. So each kid will have different IQ score. Can you average it? Answer is no, because IQ score comes under ordinal level, in which only median and percentiles are valid operation to summarize, not mean or sum is not fine for it. So it all depends upon the level of measurement, which I have already explained to you. Please review that chapter. And also remember that the sample is a subset of a larger population. Usually population remains hypothetical. So for example, all smokers in India is a hypothetical population which is existent, but it's impractical to survey each and every smoker in India. While we take a cohort of samples, for example 500 non-smoker, they are the subset of a larger smoker population of the India. So this subset is called sample. So sample is used as a proxy to infer things about the population. That is the difference between population and the sample. So all of these descriptive statistical measures have got different notations. For population, for example, mean, that is arithmetic mean or average. Population have got mu, that is the symbol or the notation for that, while mean for the sample has got another notation. So as a variance, standard deviation, median and proportion, everything has got different notations for population as well as sample. This is needed because unless and otherwise you actually label it that it is actually what is being measured is the sample mean, not the population one, because the calculations are different. For example, standard deviation for the sample is different than standard deviation of the population. So you have to differentially label it. First is arithmetic average or arithmetic mean, or also known as average. Sum of individual values in a data set divided by the total number of values. So that is total number of value means it is basically the sample size. For example, if you have around 20 students in the class and each one has got different marks, so you can calculate an average mark of the class by totaling the entire mark divided by 20, that is the sample size. It is very simple one, everybody knows it, what the arithmetic mean is all about. So it is also known as average. So here is an example, calculation of mean, which is a small population, which is only 5 individuals of this population. Index is just serial number 1, 2, 3, 4, 5, and X is the value of these people. These are, for example, let us say these are systolic blood pressures 70, 80, 95, 100 and 125. So you can calculate the sum of it. Sigma is 470 divided by the total is 5. The number of people is 5. So for total divided by the number of elements, that is size, is 470 by 5 is 94 is the arithmetic mean of this one. When do you use arithmetic mean? Mean is used for normally distributed data set that are from ratio or interval scale. As I told you, the mean does not make sense in ordinal level or nominal level. So there is no point in calculating mean for that. Median is appropriate if your measurement level is ordinal. And also mean is useful only if the sample comes from a population that is normally distributed. Small departure is tolerable, but if the departure is too significant, then no, mean is not a good measure at all. So the average human has one breast and one testicle is one of the humor. See, that is the thing, that if the distribution is not normal, then there is no point in going for this mean, and mean conveys no meaningful information at all in skewed data sets. So mean can be used either for the discrete or for the continuous variables, so no problem with that. And what is the unit of the mean? It's the same unit as the measurement. If you are saying about the blood pressure, then it's mmHg is same for the mean as well. Mean can be computed if some values are 0 or negative. There is no problem computing the mean if some values are negative or 0. Mean is significantly affected by the extreme values, non-normal distribution. So outliers actually tweak the mean a lot. So that is why the mean is extremely sensitive to the outliers. For example, the average income of India. For example, what is an Indian, how much is the average income. So, this average income, if you remove top 10 multi-billionaires from India, then the average incomes drastically reduces, because the outliers can actually squeeze the average a lot. So, that is why GDP per capita nominal, if you look, it's actually our status is extremely bad, but still it's higher than if you're going for a median. So, I'm going to come up now later. So, median is far better, because median is not affected by the outliers, but mean is affected by the outliers. So, average income, GDP per capita, this is purchasing power parity adjusted level, that is actually the purchasing level. So, in that one, India's level is bit higher than non-PPP adjusted nominal average income, but still average income is not a good measure, because average income is extremely affected by the outliers, especially the rich people. Another kind of mean is known as geometric mean. So, the geometric mean is actually very simple. You just have to, instead of adding everything, you just have to multiply each value and then calculate the nth root. For example, if you have 8 individuals in whose geometric mean is being calculated, value of 1 multiplied by value of 2 multiplied by value of 3 all the way to 8, and you have to take the 8th root. So, square root is for number 2, then cubic root is for number 3, and you can calculate the 8th root by the function called power in the Excel, or you can also do this one in a log chart. So, it is actually quite simple to do this one in the log. So, geometric mean is useful for log normal distributions. So, several distributions in biology are log normal. So, for that geometric mean is the best option for it. For example, EC50 values, IC50, that is inhibitory concentration 50 values, and for the drug plasma content, Km, Ki in the enzyme kinetics, permeability and mobility, solute mobility in plant cuticles, rate of constant description, Km, Ki in enzyme kinetics, and so on and so forth. There are a lot of data sets in biology which follows log normal, for which the best option rather than going for an average is going for geometric mean. Another kind of mean is known as harmonic mean, which is reciprocal of the arithmetic average of the reciprocals of the original observations. All has to be positive. So, if there are negative, then harmonic mean is not an option for you to do, and also 0 values also you cannot calculate the harmonic mean. So, harmonic mean is that first you take the reciprocals, then average that all these values, the reciprocal values, and then you take the reciprocal of the average of that value. So, that is what you call the harmonic mean. So, for geometric mean, the function in Excel is equal to geomean, Geomean, that is a function. So, in Excel each and every function starts with equal to sign. So, all you have to do is in the Excel spreadsheet you have to enter equal to, then put this appropriate function to calculate it. So, equal to harm mean is harmonic mean, har mean. So, original observation, let it be x1, x2, x3 all the way to xn. Then reciprocals are 1 by x1, 1 by x2, 1 by x3 all the way to 1 by xn. First you have to calculate the arithmetic average, that is 1 by x1 plus 1 by x2 plus all the way to 1 by xn divided by n. That is the arithmetic average of it. Now, harmonic mean is the reciprocal of this arithmetic average. It's very simple, n divided by all this sum of the reciprocals. So, that is called the harmonic mean. So, harmonic mean is useful for reciprocal or inverse distribution. So, certain distributions are reciprocal or inverse distribution, for which harmonic mean is very useful. Now, let us have a mini reflection point here. So, distributions of frequencies of permeability and solute mobility in plant cuticles usually are skewed to the right, That means, it is actually mode is on the left with a long tail going towards the right of the distribution, and it's log normal. The distribution is of course log normal. What kind of mean is appropriate for this data set? You may like to pause the video right now. So the appropriate this one is mean is actually geometric mean, because distribution is log normal. As I already explained to you, for log normal distribution, geometric mean is the most appropriate one. So the summary of this section is that the descriptive statistics is a handy tool to summarize and describe salient features of the data set. If the data set is exhaustive, for example, Census of India, descriptive statistics enables us to summarize the raw data into meaningful numbers. But as I told you, probably the best option rather than going for a descriptive statistics just to summarize the data set is going for a box and whisker plot. Broadly, there are two types of descriptive statistics. One involves measures of central tendency, also known as point estimates, while the other involves measures of dispersion, also known as interval estimates. Commonly used point estimates are arithmetic mean, that is average, geometric mean and harmonic mean. Arithmetic mean is example of a parametric statistic. It makes explicit assumption about the nature of the frequency distribution. For arithmetic mean to be meaningful, the samples should come from a population with a frequency distribution more or less normal, that means bell-shaped Gaussian. Arithmetic mean is most affected by the outliers, extreme values, while harmonic as well as geometric means outliers are less affected. But if you go with a parametric tool like median, which I am going to explain later, it's not at all affected by the outliers. Geometric and harmonic means are parametric statistics. However, these do not get much affected by the outliers. If log transformation normalizes the distribution, geometric mean is used, while if reciprocal transformation normalizes, harmonic mean is used. Thank you so much for watching.